multiplying and dividing rational expressions. So I'm coming in. All right. Okay, and that a rational expression, what this is going to be a polynomial over another polynomial. And we'll be dividing and multiplying the two. So the good thing with these is it'll work just like fractions, like with normal integers. So like the abstract theory of this is if we have AC over BD as our polynomial, and we're going to multiply it by D over C. What we're going to do here is we'll just do a lot of canceling and a lot of factoring to make it look a whole lot nicer, so we can end up graphing it. It'll just make it a whole lot easier. So what we're going to do with this is if we have this as just a normal number, we have, say, 6 over 15, what we'll need to learn how to do is to factor it, break it down. So we'll be able to cancel it, and this one obviously breaks down to 3 over 2, 3 over 5. Then the 3's will cancel and give us 2 over 5. It's just a pretty simple example. So we want to start with a polynomial. Our first example we'll start with 5 over x minus 1 times x minus 1 over 25 x minus 2. What do you think our first step is going to be?
Cancel the x minus 1.
These cancel? And what else?
5 doesn't have 25. Minus 3.
Okay, and so then what we'll do here is it'll just multiply like a normal fraction and just go straight across. So on the top we still have 1. And then on the bottom, what are we left with? And that's pretty much all we do. But it'll get much more complicated, sadly. It's still the same concept. So for this one, you can distribute it or you can leave it, but it's probably best to distribute. So we'll end up with 5x minus 10. So it'll be easier to graph it that way. Okay, we'll try another one. What would be our first step? From where?
Top.
Do you want to cancel this 5y with the 10y?
Yep.
And what's that going to leave us with?
1x or x squared and 5 for 2 on the bottom.
Okay.
Then you can do that with the 6x. You can take the 2 out. So just make it 3.
Okay. Anything else?
You take the x from the bottom.
Mm-hmm.
Yeah, so, and then that's not with the top, so you're setting up with that.
What will we end up with? Or,
X squared.
okay.
And you can take out y
So then you can take out what?
Or no,
Y squared is
and
still
then
y
y
on the
squared.
bottom.
So you just leave y.
And that will leave y down here.
Yeah.
All right, through all that mess, what are we left with?
X
Squared.
squared over y.
Are we leaving anything out?
Turn to.
And then we can just multiply it across. All right, and this one This one's gonna involve some factoring. Factoring will probably be the best thing to do first when we start here. So, we factor this one, or what will we do to this top one to simplify it? Okay. This will leave you with okay. And what about the bottom? This one. When we factor that, what will we do? Plus 3x minus 1. Okay. And how about this other side? Right? The bottom one is leave as 4x. So what can we cancel here? 4x. Anything else? Okay, these ones right here, to try and get rid of those, what we'll do is to this top one, we'll take a -1 out, which would leave us with x plus 1. See how that works? Okay. So we can, wait. Be x minus, right? Okay. And then we can cancel that with the bottom, and what are we left with?
Negative over negative x minus 2.
And the numerators are gone, and the denominators. So then what we can do is we can simplify that, -x plus 2. So with these ones, when you end up seeing 1 minus x with an x minus 1, you just take that -1 out and leave it there. So just remember that as a simple rule. That is multiplying, which is very important to do the factoring first before you do anything. It's a whole lot easier to simplify. And then with division, it works like fractions still. We have a over b divided by c over d. Remember how you do that? Yep. And a little phrase that I always learned how to do it is you keep it, change it, flip it. So you keep it, then you change it, and flip it. And that's how you do that. It'll work the same way when we're doing the polynomials. And the way Mr. Street will teach it is you flip it and factor. So just remember to flip the second fraction and then just factor it out like multiplication. So it ends up this way. Try the other one. Okay, what will our first step be? And then factor. What needs to be factored? Okay. And what does it factor out? And then just simplify. What can x minus 1? Anything else? That's the square root. Leave us What's the first thing that you think we need to do?
Put x plus 3 in the whole.
Beautiful. Let's just do this. And then what?
Active?
What was our first step?
Oh.
You keep it, and we're gonna change it, and flip it. And what's our factoring for this? Okay, so how do we factor this top one? Is that down here?
X plus 3, x plus 2.
And the top one will just stay the same. What do you do with the bottom? And what is going to cancel?
The X plus 3. And X plus 3.
Anything else? Could you? Do the, no, here if we tried to do that negative trick, if we tried to do that, we would end up with a 3 minus x, and that would cancel out with that. So that is what we are left with, x minus 3 over x plus 3 and x minus 2. And does everyone know, up here when we had that -1, they know that you can take that into the denominator? Oh,
Wait, what?
if you have like x to the -1, do you know how to get rid of the negative? Okay, just making sure everything. All right. Try this one. Okay. So what's our first step? Keep it. We're gonna keep it. And change it and flip it. Okay, then we need to do our factoring. What is this top one factor as? It's the difference of 2 cubes. Remember how to do this? Does that help anyone? No? Okay. So this is our A and our B. So we're doing the difference of 2 cubes. Come down here and it's A, which will be x, and B is just 1. So we come over here and we'll have A squared plus AB, and then B squared. And if that had been, say, an 8, we would have taken the cube of it. So these would have all ended up being 2. Do you see that? Any questions on that one? Okay. Now x plus 1. And what do these factor as? Do they factor? top?
What's imaginary?
Would that check out?
It's imaginary.
Okay. So this one would be imaginary, so it doesn't factor for now. We'll just leave it as x squared plus 1. And what's the bottom? Right? The difference in two squares? Okay, and then simplify.
Get rid of that exponent.
Anything else go away?
Could you do the x plus 1 and the x squared?
You're gonna have that x squared, and that's not the same. So it would be 1. No. When they're like this, they're grouped together, and you can't just break them up.
I think Lexi's question was, could you cancel, is this right, Lexi, the x plus 1 in the denominator with the x plus 1 directly above it?
Yeah. No, because when they're in the parentheses, you can't take out of the parentheses without changing the meaning of the fraction. So here, that's what we're left with. It doesn't make it much prettier, but that's what we're left with. Someone to factor multiplying.
Yeah, I think that's great. It's just going to be a lot of work for something that doesn't look much better.
Yeah. All right, I think you guys are ready to try them with the board. Okay, first group up. I just thought I'd inform you on something. I don't know if you either. Yeah.
I think we allow it to have that right away. That's okay.
Yes, you did. This is a big crash. What if we don't want to use this? You have to.
On this one,
Oh, yeah, we did.
Yeah, so that's exactly the way you think of it. And then remember that once you go to division,
I can't write it like that.
Plus X.
what you have left, you
Why am I so tired?
It's enough for on the board. Can you just give me this on
Because you still have to. It's like x plus 1, x plus 1, x plus 1. So you're going with this, and then x plus 1. It's the only thing you want. And then
Text next time.
Oh, I don't know what they got. Why?
So sorry.
Okay, stuff like this.
That was a bad
Did you guys get, I'll get that one, understand it? Did I hear a no? Okay, so what we did, we just took this up as a division, or we just flipped it and brought it up here. Then we canceled the squared with the cube, which left us with 1, and the squared was 1, which will leave you with x squared plus x. Did y'all follow that one? Okay, second group ready?
Give me some whiteboard. I know it's not wrong.
It's a little bigger this time.
Geez, can you move your head, please?
I like this one.
My bad. Yep. I don't have my back.
I'm trying to.
Yeah. What'd you do then? Well, I don't know. She said that. Okay. You can't break up like words. I don't know. Can you break these up?
You can factor them.
Can you? Yeah, I know. They look hard to factor. Gosh, this looks like too much work. She said you can't cancel like one just to start. She said you have to do that one factor. I don't know. Why? Yeah. Ask her if that's okay. Is this right? Is that how you factor? That's fat. So, okay, now we have
See that bottom one? Do you see anything in common that you can pull out? It doesn't factor, but you can pull something that's in common out of it.
out of that?
You can multiply.
See how both sides have like squared in it? Try to work squared out. See what that looks like? Right. Yeah, see how there's an x cubed? And then if you pull an x squared, it'll leave another, it's just an x.
But I already factored this.
Right?
I have to stop one.
Okay, are you looking at the bottom one now?
Yeah.
Have this.
You can't factor it, but can you pull it out?
We're gonna pull this x.
Yeah.
Oh, I thought you were talking like out of here. I was like, I already factored it. Yeah, I was. There you go.
Do you have to factor it? Before you pull stuff out, like if you see something in common, you can pull it out.
X, and then,
Oh, yeah.
I like that one.
You can't factor the bottom one. It's impossible. You can't just. Oh, maybe we have to use quadratic. No, I just did.
This adds together, this adds
Yeah, do there.
I got it.
Stop here for Can you factor that bottom one? That's a parenthesis.
So it's gotta be, first come first has to be, signs have to be, say, positive, multiply these two lines squared.
Oh, very good.
Right, I think that's it.
Multiply to be two lines squared. Y times.
What about if there's like X plus Y? X plus Y, yeah. Okay.
It's right there. Right there.
Is this as far as it goes? That's actually a lot of fun. Oh, yeah. Oh, no. Oh, we need to take out.
It's so funny. And they have like tools and what they do. Like jackhammers, They have a really nice bass in that song. Yeah, dude, it's so good.
We had it an hour every time, but then we kept scrubbing off.
I heard that one song about Wizard Game.
Okay, hold on.
Oh, that's
I am getting it. I also
1 through 19.